The journey of a precision rocket begins in the forge, where raw elements are fused into aerospace-grade alloys. Strength is engineered through force, creating materials capable of surviving the violent acceleration of launch. We refine the metal to microscopic standards, ensuring zero imperfections in the rocket's structural core. Composite materials provide the perfect balance of weight and rigidity, essential for long-range tactical precision.
Every gram of material is verified against strict defense specifications before it enters the production line.
Composition verified. Plate is certified for defense use.
Secure logistics ensure that the building blocks of defense are moved with absolute traceability. We carve the geometry of flight with pressurized water, maintaining the metal's integrity without the risk of heat warping. Strategic inventory management ensures that mass production never stops, feeding the line with a constant stream of quality. The raw materials are ready. Now, we begin the high-precision transformation into a tactical rocket airframe. Movement within the facility is a delicate dance of mass and precision, protecting the integrity of every flight surface.
Autonomous logistics eliminate human error, ensuring that every component arrives at its station in pristine condition.
Validation is constant. We monitor the health of the hardware at every meter of its journey through the plant. Sensitive components are shielded from the environment, maintaining the chemical stability required for high-altitude performance. Absolute cleanliness is the foundation of reliability, removing the invisible threats that could compromise a mission. We have reached the heart of the operation, where individual components are fused into a singular tactical asset. Every millimeter is accounted for, ensuring that the physical machine perfectly matches its digital blueprint. Precision electronics move in parallel with the structure, ready to be nested within the rocket's armored shell. The components are staged, the logistics are complete, the construction of the flight-ready system now begins. In a world of constant surveillance, the birthplace of precision flight remains hidden behind layers of impenetrable security. Every entry is a calculated risk, mitigated by a rigorous protocol of human and digital verification.
Biometric scan initiated. Scan complete. You are cleared to proceed.
Total transparency within the facility is the only way to ensure the absolute integrity of our tactical supply chain. Access to the assembly line is the highest clearance a technician can achieve, requiring a fusion of identity and trust. In rocket manufacturing, the smallest static spark is a catastrophic threat. Our gear is our first layer of defense. Absolute environmental control is vital. Even a single speck of dust can compromise a supersonic flight surface. The facility is a living organism, optimized in real time to ensure that mass production never sacrifices precision. Beyond these barriers, raw engineering meets industrial force to shape the future of aerospace defense. We have entered the core. This is where abstract mathematics becomes a physical force of nature.
Forging at extreme pressure ensures the molecular structure of the rocket is dense enough to withstand the friction of the upper atmosphere.
Lasers provide the micron-level accuracy required for sections that must join perfectly at hypersonic speeds. Every gram counts. We machine away excess weight without compromising the structural integrity of the airframe. Flow forming creates a seamless, high-strength cylinder capable of containing the massive internal pressures of solid propellant. Strategic apertures are cut with thermal precision, ready for the integration of high-speed control surfaces. Controlled thermal processing ensures the metal remains ductile enough to flex under stress rather than fracturing. Composite components are shaped with specialized tools to prevent delamination, ensuring peak performance in flight. In rocket mass production, consistency is the difference between a successful mission and a catastrophic failure. The skeleton is forged. The components are ready. Now, the rocket begins to take its final shape. Aerodynamic stability begins with perfect alignment, fusing the guidance head to the rocket's structural spine. Friction stir welding creates a molecular bond, ensuring the airframe remains rigid under the heat of atmospheric friction. Internal bulkheads provide the structural skeleton, separating the propulsion from the sensitive guidance systems. Chemical bonding complements mechanical fastening, distributing flight stresses across the entire airframe surface.
The control surfaces are the muscles of the rocket, requiring a chassis strong enough to withstand rapid directional changes.
The engine mount is the focal point of all thrust. It must be the strongest joint on the entire vehicle. Integrity is built from the inside out, securing every internal pathway against the violent vibrations of launch. We verify every millimeter of every seam, ensuring the rocket is a singular, unbreakable vessel. The armored shell is complete. Now, we give this tactical machine its digital brain and precision senses. The flight computer is the nerve center, processing thousands of atmospheric data points per second to maintain course.
Precise navigation requires perfect balance, ensuring the internal gyroscopes can feel the slightest change in motion.
Redundant data pathways ensure that instructions from the brain reach the control surfaces with zero latency. The eyes of the rocket are digital, calibrated to track targets through smoke, darkness, and electronic interference. Continuous monitoring ensures that every component is communicating perfectly before the shell is permanently sealed. Instantaneous power is vital. These thermal batteries provide the surge of energy needed for aggressive terminal maneuvers. Safety is built into the hardware, ensuring the system only activates when the exact flight parameters are met. Global positioning data is filtered through specialized sensors, providing a secondary layer of navigational certainty. The machine is now self-aware, its digital mind is calibrated, and its senses are sharp, ready for final fusion. Robotic orbital welding ensures structural perfection, creating a fuselage that can withstand the violent vibrations of a Mach 4 flight. Quality control is automated and absolute, leaving no room for microscopic fractures in the rocket's skin. Smoothness is a tactical requirement. We eliminate every burr to ensure the rocket glides through the atmosphere with minimal drag. Every fastener is a critical point of failure. Automation ensures that tight enough is never left to chance. Cold spray technology allows us to reinforce the airframe's most vulnerable points with zero thermal distortion. We test for leaks at the molecular level, ensuring the rocket's internal systems remain pressurized in the vacuum of the upper atmosphere. The physical machine must match the digital ideal. Our cameras verify every curve and bolt in a fraction of a second. Even the movement is a feat of automation, ensuring that the asset is never touched by human hands during its most sensitive phase. Preparation is the key to a perfect finish, shielding the rocket's eyes while we apply its tactical skin. Surface preparation is a science. We create a microscopic texture that ensures our tactical coatings will never peel. The first layer is a chemical shield, protecting the structural integrity of the rocket from the relentless attack of the elements. Thermal management is the difference between a successful strike and structural failure in the high-velocity friction of flight. Human oversight ensures that the robotic application meets the strict tolerances required for aerodynamic balance. The final skin is an engineering marvel, designed to minimize resistance and maximize the kinetic energy of the system. Curing at precise temperatures ensures the coating can survive the transition from freezing storage to the heat of combat. The control surfaces are the final addition, providing the agility needed for high-precision terminal maneuvers. Electrical integrity is as vital as structural strength, shielding the rocket's brain from its own speed.
Decal is secure, air bubbles out. Numbers are aligned, it's clear for the chamber.
The finish is complete. From a raw aluminum tube to a precision-guided asset, the machine is ready for trial.
We subject the airframe to the fury of a launch before it ever leaves the ground, ensuring zero structural failure. The test is complete. We have a structural pass.
From freezing silos to the friction-heated sky, the system must remain operational across every thermal extreme. We harden the digital brain against electronic warfare, ensuring the mission remains on track despite enemy interference. The rocket flies 1,000 missions in the lab to ensure that its first real flight is its last. Every internal pathway is a lifeline. We verify every seal to prevent catastrophic failure under the pressure of flight. Precision is nothing without durability. We push the control surfaces to their limits so they never fail in combat. The system is only dangerous when it needs to be, with safety protocols verified at every stage of the build. We balance the Titan with the precision of a watchmaker, providing the stability needed for supersonic flight. Proven under every conceivable stress, the rocket is no longer a prototype, it is a mission-ready asset. Conduits clear. In the final phase, even the smallest detail is scrutinized to ensure absolute perfection before the asset is surrendered to the field. Protection continues even in rest. Specialized environments ensure that time and humidity never degrade the system's readiness. The digital identity is locked, making the vessel a secure and traceable node in the National Defense Inventory.
Encryption module engaged.
Ready for immediate deployment, this silent arsenal is the result of thousands of hours of precision engineering. The journey from the factory to the front line is a transition of power, moving assets to where they are needed most.
Another successful production cycle ends as the nation's newest deterrent moves toward its strategic destination. And this is how modern defense factories build advanced systems from start to finish.
Engineering the future of security, one precision component at a time.